Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem sum root to leaf numbers. And in this problem, we are given with a root of a binary tree containing digits from 0 to 9 only. And each root to leaf path is in the tree represents a number. For example, root to leaf path 1 to 2, 2 to 3 represents the number 1 to 3. And what we have to do, we have to return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in 32-bit integer. Cool. So we don't have to deal with long. And a leaf node is a node with no children. Okay. So to summarize, the root to leaf path represents a number, and we have to find the total sum of all root to leaf numbers. So let's understand the problem statement better by looking the examples. In this example, we are given with this tree, and if we take 1 is the root node and 2, 3 are the leaf node. So first root to leaf path is 1, 2, and the second root to leaf path is 1, 3. So let me just write it. So we go 1 to 2. So the root to leaf path is 1 to 1, 2, which is 12, and here we have 1 and 3, which is 13. 12 plus 13 is 25. So we return 25. And the next example we have is this. In this, the root node is 4 and the leaf nodes are 5, 1, 0. And what are the root to leaf paths? So we can see, we go to 4 to 9. Then we have here 49. And next we go to 9 to 5. Then we have 495, and here similarly 491 if we go from 9 to 1. So 495 plus 491, and here we go from 4 to 0, so it will be 40. 495 plus 491 plus 40 is 1026, so we return 1026 as our answer. So these are the examples. So how can we solve this problem? So to solve, we have to traverse the tree. So to traverse the tree, we have two algorithms. One is depth first search, one is breadth first search. So in depth first search, we have again pre-order traversal, post-order traversal, and in-order traversal. So we can use either depth first search or breadth first search to solve this problem. So the depth first search is similar to how we have taken the examples. We went depth first, and we got 495, then we got 491, then we got 40. That's one way. Or else what we can do is first we are at 4, then we traverse this layer, then we go this layer, and we get here 49 and 40. And if this is the leaf node, then we add it to the sum. So we add 40 to the sum, and we traverse the next layer and we get 495. 495 here, you can write 495, and then we have 491 here. So we check if these are the leaf node. If they are leaf node, we add it to the sum. There is no next layer, so we stop the execution. This is BFS. And how we did before is DFS. So for the solution, for the code, I will be using DFS. So let's get started. Let's code it up. So firstly, I will take a total sum variable to keep track of the sum. Total sum equal to 0, and we return the total sum. And in between, we call the DFS with root, and we also have to keep track of the current number. So let it be 0 for now. 0, which starts with 0, and then we keep adding the numbers. So next we have to implement the DFS function, void DFS, tree node star, root, and here we also have to pass the total sum, right? And we have number, and we take the total sum by reference. Cool. Now, if the root is null, that's one case we have to handle. If root is null, we just return. Here we are doing the pre-order traversal, because first we have to add, if we are here, we get 4. And before going into the next notes, we have to add 9 to our number. So to make it 49. So we do a pre-order traversal. And if root is not null, root has some value. So number equal to, we have to add it to our number. So number into 10 plus root's value. And now we go to root's left and root's right. So do that. If root dot left is not equal to null, then let's do it in a single line. DFS of roots left, comma, what the number and the total sum. Cool. If root right, then DFS of root right, comma, number and total sum. Cool. Now what we have to do is, we have to, if root dot left is null and root dot right is null, in this case we are at a leaf node, so then we have to add the current number to our total sum. So let's do that. If not roots left and not roots right, then we total sum plus equal to the current number. So let me close this. So this looks good to me. What we are doing is, firstly we are calling the DFS on root, and if root is null we just return, or else we add the current number to the number and we go traverse the left, traverse the right. This is small u. And then if it's a leaf node, we add the current number to the total sum. Let us run the code. Hopefully it passes. Okay, this is void. My bad. It passed all the sample test cases. Let us submit it. So it passed all the test cases. The time complexity will be the same as the DFS time complexity, which is O of n, we can say, where n is the number of nodes in the tree. And space complexity will again be O of h or O of n, where n is the number of nodes in the tree, because there is a recursive call stack involved. Yeah, so that's the solution. I hope you have understood the solution. If you did, make sure you hit that like button and subscribe to Coding Charms for more daily content.